All right, let's resume. I'm going to show you guys two other ways to do things. I'm not going to have you guys follow it, but I'm just going to show you different ways to write basically the same code. Sorry, I'll look through this. Okay. So as you guys can see, we have this line that we wrote we have our 2 lines of code that we wrote in our awesome program. Game over. So when I talk about namespaces, you basically every time you type in something like this, you have to write these namespaces, and it can kind of get a little cumbersome to do that all the time. Like I just want to write std everywhere. So if I did this if I wrote this line of code multiple times like this, I basically have to do std in front of everything. And there's a way you can do it without having to write std in front of everything. You can actually just, if you want to, you can delete these here. And you guys don't have to follow along. I'm just showing you this. Do you see the little red squigglies? It's because now it doesn't know what this object is because we used to tell it where it was. And if you want to, you can basically say, hey, just assume that I'm using the namespace that's called standard. And what this will mean is that, oh, cool, okay, well, I guess that means that anytime I'm going to look there and just assume that you are pulling objects out of that location. So this right here means if you do this right here, you can do this instead of typing std : everywhere. And you can still do std : but with putting this at the top, you'll be able to just write this code like that. All right?
Will that go for the entire code?
This is for this entire file, only this file. Yeah. All right. The other way you can do it, instead of using the entire standard namespace, this is almost like opening up the entire folder and say, hey, I want to use everything in this folder. You can actually say, I'm going to use specific things. Like I'm just going to use standard cout. And here I can use standard endline here. So this means that just for cout, I'm using that specific version. But for endl, the end line, I still need to actually specify it. Otherwise, it won't know. Okay?
So then would you still need cout and game over?
Yes, because this is just, so this is kind of weird, right? This is not saying that I can just delete this. This is saying that I don't need to do this everywhere. Okay, it's basically letting me get rid of this. We don't really use this too much. We don't even use this too much, to be honest. For the most part, it's kind of interesting. In Overwatch, we don't use a standard namespace really, but when we are using a namespace, we always are explicit about using it. We are okay with copying that and using it multiple times because it's more clear as to what your intent is. We have things like camera system, I don't know, we don't have this yet, but shake camera, I don't know, by 100. I'm just making this up for 0.5 seconds. We have stuff like that. If I want to shake it multiple times, I would just do that every time. Right? So if I had a namespace for camera system, which you can make your own, I would do this instead of doing using namespace camera system. I would never do that because this is much more clear than deleting it and doing this. Okay. So that's just, even though I'm showing you guys this, I'm showing it to you so you guys know that it can be done that way. But for the most part, it's not. This isn't something that you're going to use a ton. You're probably going to use this maybe I don't know. In the early stage, you're going to use it more often than not, but more likely you're going to use it once a month, if that. All right, so let's do arithmetic. So I have this program. So I want you guys to write this program up, but I'm going to explain the bits and pieces of it first. No, you can just do it in the same file. That's fine. You can. You guys are going to use the same file for your lab work. I'm not collecting lab work. I'm going to give you guys homework anyway. So this is all for your benefit to follow along and make sure it works on your machine. Actually, I'm recording this. So built into C++, there's a lot of operators you can use for math. And math is kind of important for games. It's not like the crazy kind of math like linear algebra or calculus that you might have to do later, or physics-driven math for detecting collisions. This is basic arithmetic, right? This is the kind of stuff you learn in 3rd and 4th grade. I think you learn in 3rd and 4th grade. I don't remember what grades you learned, like adding and subtracting and dividing in there. There's a few on here that you might not be immediately recognizable, like this guy here. That's the modulus operator, which I'll get into. But arithmetic is super important for games, right? Like, I just did 10 damage to a monster. He had 100 health. I need to figure out how much health he has, right? So he has 90, right? Or I'm going to roll a dice between 6 and 10, and I need to add that to my stats that I gained. Or I need to figure out if I need to add this much weight to my inventory because I just picked up an item. Or I need to take, I have Tetris, and I have like 10 columns of Tetris blocks. I need to draw every single one of those blocks. So I need to go through every block 10 times and draw them. That's another example. Modulus is interesting. So this one here I want to just briefly touch on because I don't think it's clear. Like, you guys should understand, this is addition plus subtraction. Multiplication is the asterisk up here. Division is just the / symbol. And you have the modulus operator here. The modulus operator will return you the remainder from a division operation between those two numbers. So 7 modulo 3, does anyone know what the remainder of that division operation is? What's 7 divided by 3? What's the remainder of that? The remainder. If I divide 7 by 3, what's left over? 1, right? So that's what modulo returns. It's 1. Why is that? Why would you ever want to use that? Does anyone know why you would want to use a modulo operator? There's two kind of big reasons why you want to use modulo. One, you can use modulo to figure out if a number is even or odd. Why is that important? Why do you need to know if a number is even or odd? Or maybe, like, let's say I want to spawn some monsters, and I want to spawn them on every other block, right? Maybe I'm making a Fire Emblem game, and I want to spawn monsters on every other block, or every 3rd block I want to spawn them, right? Right. So this thing here, we'll get into more examples, but for me, the most common thing is you want to do something on an interval. So you want to do something every 10th time, or every 3rd time, or every 100th time that you want something to happen. Maybe you're making a gun for Call of Duty, and you want it so that every 10th bullet it fires a tracer round, like it fires like something that lights up. Well, you could just take the number of bullets that you fired, modulo 10, and if that modulus operator returns you 0, that means that you're on the 10th version of that number. Let me write this down a little bit. I might have a brighter marker. Aha. I'm going to give you guys that example. So I'm going to give you guys an example of modulo 10. Maybe let's do module 9 because it's a little bit easier.
Yeah, that's what I figured.
See that?
Yeah, I'm not sure. I just didn't know if you liked it like that.
I figure out the best marker. Is that better?
Yeah.
How many times does 9 go into 0? 0 times. And what's left over?
Okay, hold on for seeing that good.
Oh, you could just click right here. If you just mouse click.
Yeah. But that's not good. That's not a completing a program. This way, I complete the program.
How many times does 9 go into 1? Oh, sorry. You guys were right. 0. 9 goes into 1 goes into 9 goes into 1 0 times, and there's a 1 left over. Right? That's how much is left over after the division. Right? So if I keep going down here, and I have 9 here, what does this equal to? How many times does 9 go into 9? 1? Well, what's the remainder?
0.
That's the key. That's what the modulo gives you. Reason is, why is this simple? Why do I know that it's 0? Well, I can write code that says, when this thing is equal to 0, do something. Spawn a tracer around. Create an enemy. Player takes damage every 4 seconds. Right? Every 4th second, deal damage to the player. Maybe he has a dot on him. Maybe I want to spawn the players every 10th second. So there's a respawn wave in Overwatch. There's no waves in Overwatch, but if we were, every 10th second, I want to spawn a group of players. So I would take the time that's passed, modulo 10, and if that's equal to 0, that means I can spawn them now. Modulo is kind of an interesting thing because it tells you whether something is divisible by something. Okay? 6 modulo 3, what is that? What is 6 modulo 3? 0. How much? 6 modulo 3 is, remember, modulo is the remainder. It's not a division operation. It tells you how much is left over after a division has occurred. So you can tell whether something is divisible by something else. What is 50 modulo 2? 0. What is 1, 0, 2, 6, 4, 8, 3, 1, 4? Modulo 2. 0. What does that tell you when something is modulo 2 equals 0? If it's even, right? That's an even number. How do you guys know that it's an even number? Because it's 4, but how do you know that 4 is an even number? Because of school, right? Like it's just ingrained, you just know it's even. But if you ever had to write a function that says a number is even or odd, this is what you would do. You use the modulo. Something modulo 2, if it's equal to 0, that means that number is even. If you write that in here, if you replace this here with that number and do modulo 2, you'll get 0 on the end of it.
Maybe.
If I change this from 4 to 3, what is that equal to? 1, right? The other nice part about modulo is that it lets you get any number and basically get a range of numbers. So no matter how big this number is, I could tack on 1,000 more digits on here. The result of this modulo will always be either 0 or 1, no matter what. It doesn't matter how big the number is. That thing modulo 2 will either be 0 or 1. Sorry, 1 or 0. So if I gave you the same number and asked you guys to give me the range of values, modulo 3, what are the possible results of that? 0, 1, or 2. Okay? Those are the possible values that you can get from modulo. Okay? And if I just do this, modulo 100, what are the possible numbers you can get from that number? 0 through 99. No matter what the number is, you'll get 0 through 99 as a result. These are important because sometimes when you're writing code for a game, you need to take some random number and basically figure out what interval it's in. So whether it's, let's say you had 100 different buckets that a number could go into. Let's say you had like, an enemy can be either, let's say you're spawning random enemies for a roguelike that you're making, Cody. Or you're spawning random items that you want to drop from an item pool, right? Let's say you're making Diablo game again, or a WoW game. What you usually do is you generate a random number, and random numbers are huge typically. Like they can be anywhere from 0 to like way bigger than this, right? So like they can just go on and on and on. They can be huge, but you need to take that random number and make it into something that's usable for how many items you have. So in my Diablo game, I have 100 possible random items that I can drop when you kill a monster. I'm going to generate a random number like this. I'm going to modulo however many items I can possibly drop, and I will get some number between 0 and 99, which will let me pick from my 100 items randomly. Right? So let me take this number and get a range. Basically kind of shrink that, not really shrink, but kind of like turn it into a range of numbers instead. And that's why that operator is kind of underused, like you use this sparingly, but when you need to do that operation, there's no other operator that does that, which tells you the remainder of the operation. Like if I just did this divided by 100, I would get some other random number, right? I don't care usually about division in this case. I care about how much is left over, all right? Okay, questions on modulo? Yeah.
So
So for module, is that a way to figure out like a percent of a drop? So like say like, oh, this source has a 10% chance of dropping. Is this something that?
Yeah, so that's it's part of it. So let's say this is my random number and I am trying to figure out a percentage. So actually modulo 100 is a perfect example where I will get a number between 0 and 99, right? So actually what I can do is, maybe modulo is not the best example. Because what you normally do is you get a random number, and you'll get a random number like this, and you'll convert it to a range between 0 and 1. So you'll have like 0.4 or 0.8 or 0.2. And this is a bad example because in that case, let's say I have this huge random number. Let's say I have this big random number and I want to get a number between 0 and 1. Because this is what percentages are based on. You're talking about like drop percentages, like I either have a 50% chance to drop something or a 10% chance to drop something. What normally you do, instead of doing it from, if I do 0 to 100%, this is my chance to drop something. I'll just get rid of the 100 part on there. I'll just divide it by 100. So this is equal to a 10% chance to drop, right? It's equal to a 20% chance to drop. This is equal to 80% chance to drop, right? Equal to 40% chance. Or if I have like 0.01, it's equal to 1% chance, right? The reason why I map it is I'll actually take this number that's generated and I'll divide it by the maximum number that can be represented. So the computer doesn't actually have an unlimited number of numbers that it can represent, no matter how much you want to believe. You guys remember computers before the current generation, there used to be a maximum of 4 gigabytes of RAM you could install. I know you guys knew that.
Yeah.
But like you couldn't actually install more than 4 gigs of RAM on your machine before we moved to 64-bit operating systems. There was a time when on Windows XP, if you guys ever ran Windows XP, you can't actually run with more than 4 gigabytes of RAM. And the reason is that the computer previously didn't have enough numbers that it could use to represent it because it only could represent what are called 32-bit values, which are basically up to 4 billion. So let's see here, 1, 2, 3 million. Something like 4.2, 429 something. I want to say it's 429 something, something, something. This is like the maximum number that it could represent for numbers, which meant that this is how much RAM you could have installed. This many bytes of RAM, which is million. Wait. Or this is million, right? There we go. This is how many bytes of memory you could have. This is why you can only have 4 gigabytes. This is basically gigabytes of 4 gigabytes. And so what you do is you take a random number like this, and you actually divide it by this big number. What do you get when you divide this thing by this thing? I want to make sure that these numbers add up here. Someone bring up a calculator and divide that, or I'll do it. I'll do it on screen here right now. So I'm going to take, oops. Let's just take like 34026481313 divided by 4, 123, 123, 123. 0.85. You guys see that number? That is the number between 0 and 1 that you pick.
So the 85% chance?
Yeah, so what you do, you roll that number. Let's say you have a 10% chance to crit something in a game, right? Like I roll a dice and I want to know if I crit or not. So I roll a random number. I rolled 0.85. So what you normally do is you take that number that you rolled and you see if it's bigger than 0.9 in this case. So you roll, what are all the possible numbers? What is the likelihood that this number here will be greater than 0.9? If it's a random number between 0 and 1, what is the chance that that random number will be between 0.9 and 1? Like 10% chance, right? If I have my line of random numbers from 0 to 1, and this is 0.5, and this right here is 0.9, yeah, what is the chance that it'll go right here? What is the chance I'll get a random number right there? Yeah, 0.1, which is equal to 10%. So I roll a random number, and it's somewhere in here it's going to fall, and maybe right here it falls. Like right here I got 0.85, right? So I didn't crit here. So I need to roll another random number that's bigger than 0.9 to get that crit. Right? So modulo in this case is not really helpful, but the division operation is. All right, so let me go over it a little bit more. So that's the modulo, and I guess I covered the division. I'm going to go down one at a time. So here's what this line is saying. Hey, C out. So notice here it's using the namespace up at the top, and it's saying write to C out. This 7 plus 3 string, so it's writing this out. This is just a string. You can have it type whatever you want to, right? This is, you can type it whatever you want in there. That's a string. It doesn't actually mean anything. This is the part that matters right there. That part right there is called the expression. So that is 7 plus 3. It's taking the number 7 plus the number 3, adding them together, and then spitting them to C out. Just like here, it's taking number 7 minus 3, subtracting them, and writing them C out, and 7 times 3, and writing them here. Okay. All right, so let's run this real quick and see what the output is. I'm going to use my breakpoint method here. I'm going to put a breakpoint here at the bottom. And make the font bigger. Can you guys read that, kind of? I don't know if that's big enough. So I just want you guys to see this for a bit while I explain what this is. The top thing, 7 plus 3, that's 10. That should make sense. 7 minus 3 is 4. 7 times 3 is 21. 7 divided by 3 is 2, right? Wait. 7 divided by 3 is more than just 2. It doesn't divide perfectly, right? You have a little bit of remainder. Someone said it was 2.33, right? Left over. It goes in 2.33 times. Wait, but I'm dividing 7 by 3 here and here. What do you guys see as the difference between this line and this line? Why does that? There's a 0.0 on it, right? Why is that important to C++ to know the difference? Why should it care whether something has a decimal point on it? They're basically the same number, right? This is 7, this is 7. It just has a 0.0 on the end of it. This is 3, and this is 3, and that one just has a 0.0 on it. Those two things are very important, though. There's a big difference between the two. What's that?
I was going to say, it lets it know it can go further.
Yeah, kind of. Because in this case here, this is what's called integer division. Imagine, you guys remember line numbers? Gosh, like from elementary school. I don't know if they teach that anymore. It's been a long time. Remember how they used to teach you numbers like 0, 1, 2, 3, 4? They didn't teach you fractions or like decimal points until later, right? Those whole numbers, which are only 0, 1, 2, 3, no decimal points, are what integers represent. So when you see int, those are, you can think of them as like whole numbers, They don't have decimal points on them. So when you divide two whole numbers into one another, it's going to give you a whole number back. So it actually knows that there's more to it, but it cuts off the rest of the decimal points because it's like, oh, well, it's elementary school arithmetic. You want to do 7 divided by 3. You don't want to worry about fractions or decimal points right now, so I'm going to give you back a whole number in return. Now, as soon as you tell C++ that you care about decimal points, it's going to start doing decimal point division. So that's why 7 divided by 3.0 gives you 2.33, all right? But you have to actually have a floating point in either the numerator or the denominator. Yeah, what's up?
So if we want a more raw number, we do 0.0. If we want a rounded number, we do no 0.0.
Right, you don't. If you want to do an integer arithmetic, you only use integers. If you want to actually have floating point numbers in the end, yeah, if you put a decimal point in there, it'll give you back a decimal point answer. Yeah.
I would assume as you're doing a more complex and a more accurate game, you're going to be always using decimal points.
Pretty much, yeah. That's actually a really good point. We don't. This is usually a mistake that someone makes.
Yeah.
Usually in games, you really care about the decimal points. They matter a ton. Imagine, for instance, that
Game engine.
Yeah, like I want to cut my health in half or something, right? Or maybe I want to, yeah, like take someone's, make my damage and cut it in half. But my damage happens to go from 0 to 1, right? If I take 1 divided by 2, what do you get back as a whole number? 0. You get back 0. It's 0.5, right? And remember, C++ will throw away what's after the decimal point, which is bad. When you actually want to say, if I want half my damage, I want 0.5 as my damage. So most of the time, you're going to want to do this decimal point math. You want your game to be precise, so usually you're going to be using decimal points. But it's important to know that you can get into a situation where it cuts it off. This has actually bitten me just like maybe 6 or 7 months ago. We still run into this problem sometimes. I still write code sometimes where I wasn't aware that I was dividing 2 integers together, and I was getting really weird values. Like I was getting 0 when I should have gotten like 0.6 or 0.7. And it was because I was dividing 2 numbers by each other. Where was this that I was doing this? It was for Reinhardt. I want to say it might have been for like Reinhardt's melee swing. Yeah, so it was because, so as part of Reinhardt's melee swing in Overwatch, as you swing, you hit people with your swing. Part of that hit is we actually like stall his animation for a second, just like bam, and then keep going and then swing through. So it feels better, kind of like a Capcom style game. If you ever play Street Fighter, like you get those freeze animation frames. So instead of just like swinging normally, he just like bam, like as if he's getting like kind of caught, on the guy. So we freeze the animation for like 1/10 of a second, right? Just freeze it for 1/10 of a second, 1/4 of a second, whatever. And to figure out how much time to freeze it for, there's some math that goes on. And the value that I was getting back was always 0. So he was just swinging. He wasn't actually freezing. It turns out that is because one of the values was not a float. It was an integer. So if both values are integers, then it becomes an integer result. Yeah.
If I have let's say, a really long equation, for example, I just put a decimal point on 1, will the whole thing be made?
Yeah. Yep. If you're division, but it has to be part of the division operation. Okay. So if either of these numbers have a decimal point, you'll get a decimal point result. But if both numbers are integers, you'll get an integer result. Okay. So it tries to do the right thing. All right, modulus. All right, so the order of operations. In one of the examples here, you can see 7 plus 3 times 5, right? So it's just like algebra, or like you guys remember it says parentheses. What is it? My dear Aunt Sally.
Addition, subtraction.
Yeah, my dear Aunt Sally, but there's like parentheses as well. Please. M dot, yeah. So it's the same rules. Parentheses first, then multiplication, division, addition, subtraction. So the result of this is 7 plus 3, which is 10, times 5, which is 50, right? All right. So you guys can run this. Hopefully. Get it to a point where it shows you the values. Did everyone get this thing to run? Everyone type this?
Yeah. I had a little issue, but it was fixed.
If you didn't get it to run, then this is part of chapter 1 for sure. We can go over it some more.
I put the main tries by accident.
All right, so let's do the next phase of this. We're going to do something called game stats. So this is a little program. There we go. A little better. Okay. So this is using an example from like a shoot 'em up game for like interesting stats that you might care about. I talked about variables briefly, about tracking things like player levels. This again, these are some examples of variable usage that show you how to track score, distance traveled, whether you want to play again or not, how many lives you have, how many aliens you killed, as well as your engine temperature. So this uses variables to accomplish that. So here, we've been using int so far, so let's start with that. So this program here declares a bunch of different variables. And I'm actually going to have you guys follow along with this in just a second after I go over this lecture, and then have you guys write this up on your own and then compile it, and we'll see how far everyone can get. So I talked about variables briefly. These right here are all variable declarations. So look at the first one here, int score. I talked about variables. They have a type and a name. So here we have a variable called score, which is an integer type. But there is a bunch of other built-in types in the C++ that you can use. So int is a whole number type. It's basically like what we've been using up to this point pretty much. It's things that are values from 0 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A double is a floating point type. It means it is a decimal. It has decimal numbers in it. It means it can represent fractional numbers. And a double is called a double because it is double the size of a normal floating point number. What do you mean double the size of a normal floating point number? Right? So variables have a limit to how much they can represent. It's weird because you would think, I can't just plug in like 1 followed by a quintillion number of 0. I can't just put in that many numbers of zeros in all these. There are a maximum number of values that it can represent. And then doubles can represent a really huge range of numbers, but there is a limit. But doubles can represent twice as many numbers as what a float can represent. So I'm going to write here a float. Because they didn't have it. A float is just exact same thing. It's exactly the same as a double, except it can represent just half as many numbers as double. So why would you use one over the other? For the most part, we use doubles as much as we can, where we need precision, where we need to represent really big numbers or really, really, really tiny numbers too. Because really tiny numbers also require a lot of digits, right? Floats save you space. And space is important because the less space you take up with your variables, the faster your program will run, the less space it will take up in memory. Also, it means that it can fit within consoles better, especially if you have a number, like it might not seem like a lot, like, oh, one variable. This one's twice as big, but they're both kind of tiny. But if you use this float variable 1 billion times compared to this one 1 billion times, the size between those two is basically the difference between like a program that takes up 1 gig of memory versus a program that takes up 2 gigs of RAM on your computer. You ever wonder why some programs take up more memory than others? Like you open up Task Manager and you're like, oh, this program seems to take up like 6 gigs of memory for some reason. Well, it all comes down to how much data these variables store and how much they represent. Okay. So these are some of the built-in types. We have a char, which is a character. Character here represents a single letter. So it's like A, B, C, D, E, F, G, H, I, J, K. Short here is like an integer, but it's half the size of an integer. It's like a smaller version of an integer. It's a way to represent something that will not really be that big of a number. You ever wonder why some games, I'm trying to think of a good game example that has a limit to how many things it can spawn. Like if you think about the original Mario Brothers, let's say, or like coins in Super Mario 64, or let's say like, you ever see how some games have a limit to like maybe bullets? You can't have more than 255 bullets.
Yeah.
Or you can't have more than like 4,096 something. Or like you can't have more than 8 something. So if you things that have a limit like 255 is usually because it's using something that's a short to represent it. Because a small number like that can only represent numbers between 0 and 255. That's it. It can't fit any numbers above 255. If you try to put like a number, and this depends on the operating system too. So I'm saying this, but it depends on whether you're running Visual Studio or whether you're running on like a 10-year-old PC or not. But for the most part, these numbers are super tiny and only used to represent really small numbers. And that also means that they're pretty fast and they don't take up a lot of room. I'm moving this down a little bit. So in this case, in Visual Studio, short represents up to 32,000. So I want to show you guys a slide while this is running. So notice here, all these variables have a semicolon at the end of them. That's how you declare a variable. At some point, you declare a variable like score, and then you say, hey, put a semicolon at the end of it. That means that this thing is saying, I want to make a variable called score, and I want it to be an integer. That name is important because that name is how you actually give it numbers and letters and values later. This name that you give it is how you use it in the rest of your code. A lot of times you need multiple variables. So games require a lot of different variables. You can use a comma here to declare multiple variables using the same type. This is saying I have a variable called lives, that's a short, and a variable called aliens killed, which is also a short. We have a coding standard to never use this stuff. We don't use commas because it tends to make it a little bit confusing, especially when you get to assigning them. So this right here is the same. I mean, it's up to you, but I would shy away from that. I would actually do this. I would literally do 2 different lines like that to make it clear. But you can put them on the same line with a comma. Keep that in mind too. Our coding standard is to not have commas in Overwatch as much as possible. So here, all the variables are declared at the top of the function, but you do not have to do that. You can declare variables anywhere. In fact, you can see here, a new variable called engine temp is declared right after all these other ones have been assigned. So there are some rules to these names, and the variable name is actually called an identifier, but you can call it variable name, variable identifier. There are some rules that you have to follow. There's a few things you can't do. You can't start a variable name with a number. So you can't actually put a number in front of these things. So you can't put like 8 or 99 in front of it. That's not allowed. And you can't name a variable the same thing as a reserved C++ keyword. So I can't name this score int. Or I can't name it return. See how it's blue? See how both of those things are blue? When it's blue, it means it's a reserved built-in C++ keyword. I can't name a variable that way. All right? Okay, so let's scroll down here. This should be the last of it. There's no limit to the size of a variable. When you're naming it, so there's 2 of the hardest problems in programming. There's 2 problems in programming that's kind of a joke, but it's kind of not. 2 of the most difficult problems that people are still solving today in game development and C++ programming. 1 is cache invalidation, and 2, naming things, which is weird. Naming things is the second hardest problem in programming, software development. Giving things a proper name sometimes takes a lot longer than you think it would. Like, you know what you have to write, you just have to give it the right name. And what's weird is that sometimes it comes right to you. Sometimes you have something really weird and specific that you try to figure out a name for. Like, let's try to do some variable names here. Give me some names for variable identifiers for things like, let's pick a game that I've been playing recently. Overwatch. Overwatch. Let's say how about how much ultimate you get back when you heal someone as Mercy? What would you give that variable name? What would you name a variable that is that number? How much ultimate you get back when you heal someone as Mercy? Return ultimate, but that doesn't say anything about healing or mercy, right?
Ultimate heal.
What's that?
Ultimate heal.
Ultimate heal? That sounds like an ability, right? Sounds like the ultimate heal. Ultimate heal regen? What is that? Is that a number or is that a rate? Is that like I regen 10 per second or I regen 10 per health? What is it, right? All right. What are the other ideas you guys have? Ultimate regen, the ultimate that you get back.
Recovery.
Recovery is not a bad idea, but it doesn't really represent like how much ultimate I get for healing. Like it's not really recovering the ultimate bar, right? I'm getting ultimate, right?
Yeah, ultimate recovery.
Yeah.
Uh,
But you're not really recovering either. Like that makes it sound like you lost it and now you have to get it back. We call our ultimate power in our game, so it's actually power, which is interesting because it's kind of a weird like thing. We also call our ultimate signature abilities too internally. So if I had to come up with a name for it, I would say something like power gain per heal, or power amount per heal. Something specific, maybe 4 words. It might even be 5 words. But again, it's not maybe the best. There's probably a better way to represent that. And it's weird because you always run into this problem with something specific that you want to say. It sounds simple, like, oh, just ultimate rage. Just give me, this is how much you get back when you heal someone. But when you're looking at it, it doesn't look like that at all. What's another thing that is a good example? How much damage is mitigated by armor when you take damage in Overwatch? So armor mitigates damage a bit. So every time you take a shot, it reduces that damage either by 5 or by half the damage amount, whichever reduces it less. Did I just confuse everyone? If I shoot Reinhardt with Tracer, who does 5 damage per shot, it reduces her damage by half. If I shoot Reinhardt with a Hanzo bow and arrow that does 70 damage, it reduces it by 5. Okay, because it reduces it by 5 damage. It doesn't reduce Hanzo's shot by 50%. It reduces it by 5, because whichever one reduces it less. All right. So what is that variable name? What is the name for that amount that it reduces the damage by? Does anyone know what you could name it? You don't have to come up with a name now, but this is what I'm talking about. Naming things is tricky, which is why variable names are important. You should take some time to think about the right thing to name it. Okay, so you can see here at the very top here, it has a new statement called double engine temp equals 6,572.89. That is a variable assignment. So you can assign values to variables that you've created. You can either do it as you declare it, or like above here. Let me make this thing a little bit bigger. So these are all variable assignments at the top, from line 19 through to 25. So the first variable assignment at 19 assigns distance to 1276. Because distance is a double type, so it assigns a decimal point number to it. I'm going to scroll up for just a second here. So play again. What type of variable is play again? What's the variable type there? You can see it above.
Character.
It's a character, right? So that is how you assign a character to a variable type. That is of type character. All right? What type is shields up? What type of variable is that? It's a bool. And a boolean is either true or false. That's all it is. Which means you have to type either true or false there. You can also do 0 or 1. Yeah. What's up?
If you did y, wouldn't you have to do the number that y represents?
You can actually do that too. They're the same thing, but this will do that for you. If you put it in single quotes, it'll convert this to a number that represents what y is.
Okay.
Lives is a short. Same with these. These are all simple numbers, and this is a double, right? Distance is a double. Same thing with engine temp. So you can either assign a variable on a new line, or you can assign it on the same line. All right, I want to take a break to show you some of the values real quick. We're not going to get to that yet. I'll get to that in just a second once I get to unsigned shorts. So this thing right here, true or false, these bools, we're going to use them a lot. They're going to be used next week as part of if statements and learning. But for now, just know that they'll either be true or false. All right, so how do you write out the name of, or the value of one of these variables? Well, all you have to do is you just have to take this variable and dump it to CI. By the way, you don't have to put this on every single one. If you want to, so see how this program is running right now and has all these things? If I wanted to, I could just dump them straight into cout without any of these things. So I could actually delete this here. If I just delete all these things, you can do that. So if I run this again, so see how I'm just dumping the variable directly to cout? And so that's what you get. Right? You just get the numbers here. But that's why the strings are here, so that when you run the program, you have a label to these variables, so you know what the variables are. So all you have to do is pump it into cout, and then you'll get it. This is a little special guy right here, the /n. Yeah, question.
For the play again function, how exactly do you get like y?
So why is that printing out y instead of true
Or no,
false?
like you said it had like y.
Oh, this
stands
thing here?
for, like stands for a value, but like how do you know exactly, or like how's it determine the value of what it actually represents? Or is it just kind of like
So there's a lookup table in code that says, oh, I know that this character y represents like probably 78 or something. It's a number, and the compiler will do that for you. It'll convert this for you as it's compiling, just like it can convert C. I think A is 65, and I want to say B is 66, and C is 67. It actually knows what each character represents. So when you type in, like in single quotes like that, the compiler will say, oh, cool, well, you probably meant this number, so I'm going to put that number in for you instead.
so like there's an actual like math table behind
Yeah.
it, like, okay.
There is something in there built into the compiler that will do that for you. It's called the ASCII lookup table. So like it will do that lookup for you as part of the compilation step. You can actually see it here. I don't know if you've ever seen an ASCII table. So ASCII tables are interesting because it's like this. So these are all the characters here. So what the compiler will do, so the number here is, the left number is the decimal number. Looks like, yeah. So left number, these are all the same number. This is decimal, hexadecimal, oct, and this is the character code. Just ignore all the columns except for the first one. So it has a table like this somewhere where it says, oh, you typed in y, you mean 121.
Okay.
Or if you typed in like lowercase k, 107. Or if you do capital A, it's 65 right here, right?
Okay.
And all these characters, like all the numbers have a character too associated with it.
What did you say this table was?
This is called an ASCII table, ASCII. And it goes from 0 all the way up to 255. From 0 all the way up to 255. There's actually a way, I should be able to do this. I want to say this should work. I don't know if it's going to actually do the right thing, but we'll see. I'm doing this live. There's a way. There we go. I don't even know if these machines have a speaker in them. Oh, they don't have a speaker. Oh. It's just muted for some reason. There used to be in the old computers, let me turn up the volume here, that depending on what you printed out from the ASCII table, some of those things aren't even letters. Some of those things are like commands to Windows to like do things like beep, make your computer beep. It doesn't work on these things anymore. PC speaker, yeah, I don't think most things have PC speakers. Let's try this. Yeah. Yeah, these things don't have PC speakers on them for some reason, but they used to be. If you printed this out, like if you printed code 7, so if you look here on the ASCII table, here, you see what code character 7 is right here? See how it says bell? That actually is like the speaker inside the computer. Have it make a bell noise. Some of these are like, if you print cout 8, it'll actually say put a backspace in wherever you're doing. A lot of these things are not really relevant to like modern computers, but like 32 is a space character.
Okay.
So yeah, you basically get that. That was what the these values are representing here. Okay. A little over half an hour to go, so let's finish up. Okay, so these are ways you can assign variables. You can also, as I mentioned before with that little trick that I showed you, you can declare a variable. Like here, you see how fuel is declared. You can also have that be coming in from the user. So the person sitting at your machine can actually type in a number. So right here, I declare a variable called fuel. I ask how much fuel do you want, and this /n basically says put a line break. So put an empty line in between what I printed here and here, so you can see it in the actual output. So see how between engine temperature and how much fuel, there's like a blank line here? That's because of this guy right here. That /n means put a blank line. So if you can put as many of these as you want in there. They never get printed out. They just get converted into a line break in the console. So see how much empty space is now between these two, right?
It's basically just another end line, isn't it?
It's just an end line, but you could put it inside the quotes. So yeah, you could also do end line in there. So if you wanted to, you could do end line. You could do this instead, like that. That's kind of the same. That's exactly the same thing as doing. But it's a lot easier and simpler to do /n than it is to do that. But you get the same thing. All right. So now it's asking for how much fuel, right? So I can say I don't know, 42,000. And so I typed in that number here. And I printed it out right here because notice here in this cout right here is printing out the fuel. Okay. All right. You can get more than just numbers here. You can actually get strings too. Anytime you do cin, you can push that into a variable and it'll convert what they typed in into a value. So this is an interesting line here. I'm actually interested to why like the exercise here has this, because this is something that is not really super useful to like you guys really, but I think it's good to know. You won't use any of this stuff for your games, but we do use this stuff a lot in Overwatch. This lets you make up your own variable names, variable types. So here's how this thing works. It's actually pretty simple. This thing says, hey, anytime I'm going to make a new variable name, it's going to be called ushort. Ushort. And that thing is actually this right here. So wherever I use this, just replace it with this. Okay? That's all this typedef says. It says typedef is, hey, current type, my new type. So I could actually name this thing whatever I want to. If I wanted to name this thing dickbutt, I can create a dickbutt type. And now it's highlighted my custom color, right? This is one way you can actually create a new variable type. It's the same variable. It's an unsigned short int, which means it's a short integer. So it's half the size of an integer. This is the same as just a short. You can actually leave this off if you want to. Unsigned means that it cannot represent negative numbers. The reason why that's important is that if something can't represent negative numbers, it means that it actually has more room to represent bigger numbers. So this thing can represent, this unsigned means I can represent twice as many positive numbers as a regular short. For the most part, like just know that putting unsigned in front of something will make it so it can't represent negative numbers. If you try to make it represent a negative number, it'll just represent a positive number instead. Okay, I talked about using variables. All right. Okay, so let me go over the second type of this. There's another version of this file. It's kind of an evolution on the other file, so let's just run this. There's a couple new operators here that are just more ways to assign variables. So here, I have a variable called score. You guys don't have to type this up. I just kind of want you guys to follow along because your homework is going to be doing this kind of stuff. I have an unsigned int called score. So it can only represent positive score values, which is good because that means that I can represent really large score. Because score is typically not negative. What are some other types of variables that can be unsigned and be okay, like in games? Like what numbers never go negative in games?
Decimals.
Decimal? I mean like ammo is a good example. What other types of things like that can't go negative in games?
Health.
HP, health? Sure, that can't go negative?
Yeah.
I mean, it goes 0 if you die though.
It goes 0 and you die. Is there ever anything called like overkill or anything like that in games? You can do that, right?
Yeah.
What about like player level? That can't go negative, right? That's always either 0 or greater. Are there any other things that can't go negative you guys can think of?
Experience.
Experience is a good one, yeah. What? Items? Item count? Yeah, how many items you have. Those are good things, yeah. So anytime that you have things like that you might actually have a lot of, experience is a perfect example because experience, usually you have a lot of it and you need to represent a really large amount. And the key is that, let me show you guys, let me write you guys a little program here. Let me just take a little detour to show you guys what I mean.
What about leaderboards?
Leaderboards, yeah, that like score on leaderboards.
Or leaderboard count global?
Yeah. So I'm going to do this little program here. I have an unsigned int for experience, right? And, oops, compiler error. Oops. I'm going to start my experience off at 0. So I'm just writing a little program here that counts up experience. Oh, it went too fast. I have an unsigned int short. I'm going to get 10 experience really fast every time. So you guys see, this is how much experience I'm getting. You ever play any of those cookie clicker games or anything like that? Numbers go up. So what's happening at a certain point? It's counting up to 30, 50,000, 60 something. It starts over, right? Counts over again. That's what happens when you reach the maximum value of a number. It hits that number and then restarts. Let me slow this down a little bit because I think you guys need to see. I'm going to do one at a time here. So see, it's counting up to thousands. So it adds, it's an unsigned short, which means it represents a small number. It's like, it was like 40 something thousand, maybe 80,000. Let me see here. Exactly how much it is. 65,535. So when that number hits 65,535 and you add one more experience point to it, it starts over at 0. Because it rolls over. You ever know, like, old games might have this problem where, like, you have a number. What's up, Christian? When did you get in?
Just like 10
All
minutes
right.
ago.
Yeah, it's going to hit 65,535 and then restart at 0. All over again. That is what an unsigned value can represent. If it wasn't unsigned, you start getting into some really weird behavior. So you don't ever want to do this. You don't ever want to have it be a short int that's not unsigned, but this thing will also work. But the problem is, so this is now something that can represent a negative number. So it should get to about half as much, 32,767. But these things have what's called undefined behavior. When you try to take a number and add 1 to it, but it can represent negative values, sometimes it'll roll over. Sometimes it'll do weird things. Here, it rolled over because Microsoft Visual Studio compiler tries to do its best to let it roll over, but that's not always the case. This behavior is bad. If you ever have something that can represent a negative number and you add 1 to it at the top range, you can't be guaranteed that it's going to roll over. Actually, this is what sometimes they call crashes in a game too. You try to add 1 to something that's not an unsigned number. All right, so then I took my little detour All right, that's what unsigned values do. You add them up. That's good things for experience. Undo all this. Okay. So here's some things about this program. You can do assignment and an expression at the same time. So you can set score equal to the value of score plus 100. So what is this going to print out right here? Anyone know? What will this line of code print out right here?
5,100.
5,100. Why is it 5,100? Because it's taking the value of score, which is currently 5,000, putting it here, adding 100 to it, and putting that back into score. This is the same as me typing out like that, right? Does that make it a little bit more clear as to what's happening? 5,000 plus 100. How did I know that was 5,000? That, right?
Equal to 5,000.
Okay. What is the output of this? So this right here is the same exact thing as this. This line is exactly the same as this line. It's just combining it two. That plus equals assignment operator means that, hey, take score and to this value, add 100 to it, which is exactly the same thing that this thing is doing. This thing is saying take score and make it equal to score plus 100. And this thing is saying take score, make it equal to score plus 100. That's why it combines both of these. It's saying plus and equal, do it at the same time. It's combined assignment operator. So what is this? Yeah, this is much quicker. We use this all the time. We almost never do this. What is this going to print out?
5,100.
5,100, I heard someone say? 200, right? Because it's still adding it to the same score, all right? All right, let's go over these. Int lies. This little guy, you see a plus plus. You might think this is why C++ is named that way. It's not. This is called a pre-increment operator. Pre-increment operator means add 1 to this thing. But do it first, add 1 to this thing, and then use this value. It's weird. That's a weird thing to say, right? So let me show you what I mean. I wonder if they actually show it here. Oh, they don't actually show it. Okay, I'm going to show this. So here, I'm just going to delete this line right here. I'm just going to run up to this point where it says lives. All that little plus plus says is add 1 to it. So right here, let me clear this up a little bit. I'm just going to delete all this for now. So I have lives, right? I just said lives equal 3. This is going to print out 3, right? Here it goes, 3. If I do plus plus in front of it, that means add 1 to it and then print it out. So what's that going to print out here? It should print out 4, right? Like so. There's another way you can write this, which is you can put that plus plus after it, which means use this variable first and then add 1 to it. So it does it in that order. It does it in the order from left to right. So what will this print out? But I'm going to print it out first before I add 1 to it. So what is it actually going to print out? It's going to print out 3. So you see here, it actually printed out 3. So watch. So it printed out 3. All I do is I do this again, and this time I'm not going to do a plus plus. I'm going to do it twice again. So notice the difference. I'm adding 1 here, but I'm doing it after, and then I'm printing it out. What is it going to print out here? 3 here, and what's this going to be? 4? Yep, 3 and then 4. And so why is that again? Because this thing, this little plus plus says, hey, do whatever you're going to do with this variable first. Get rid of everything that you need to do for this variable. Go ahead and use it. Tell me when you're done. When you're done using that variable, I'm going to go ahead and add 1 to it. All right? So in this case here, it's like, oh, cool, I'm going to print out this string lives. All right, sweet. And go here. Oh, I'm going to print out this variable first because you told me that I could. So I'm just going to go ahead and shove that into the cout, and then that's it. I'm going to print out 3. Oh, you told me to add 1 to it. Well, too late. I already used it. So I'm just going to add 1 to it, and it is what it is now. That's different from this plus plus lives, which is, hey, before you get to use this variable, I get a chance to add 1 to it. All right? So can anyone tell me what these two lines will print out? 4 here is right. What does this one print out? 4. Because this, remember, it adds 1 to this variable, so it adds it up by 1. So yeah, that's going to print out 4 and 4. So you guys can see it says 4 and 4, right? All right. Okay, so let's go and finish up this one. Okay, so that's the plus plus. There's the pre-increment operator here. Can anyone tell me? Oh, I'm moving around a lot. Okay, who can tell me what this is going to be equal to, based on what you see up here?
40.
Someone said 40? Yeah. How do you know it's 40?
4 lives times 10.
This is 4. Why is that? It says 3 right here.
Yeah, but you're adding.
Right, because I'm adding 1 to it already, right? What would it be if I push this on the right side here? 30. Correct. So there you go. There's 40, 40, and 30. What do you guys think?
Doesn't make sense.
What's that?
Discrete mathematics.
Straight mathematics?
Yeah.
Discrete math?
Yeah.
That's a little tricky for me too.
It is so pointless because it's common sense. It's so complicated because it's not based off common sense.
Oh, a good example for this, the whole like it wraps around when you hit the max numbers like an odometer. You ever, or like a time thing that rolls around from the top, it goes all the way up and it has no more numbers to represent, so it goes 99999, and then you add 1 more to it, it goes all the way to 0, right?
So how come on in this language the plus? How come 2 pluses make just 1 and not just a plus?
2 pluses make just 1. Well, plus plus is a special sequence. Plus plus just means add 1 to this thing.
Yeah.
That's all it means. It doesn't really mean anything else. If you want to just add something to it, you just use 1 plus sign. Maybe I'm not understanding your question though. What are you
Yeah,
trying
I'm
to
just
say?
saying like you know how come just plus you know.
Plus is used for addition normally.
That's just
You mean why don't you just do this? You mean?
yeah.
Because this means you're trying to add something to it, and C++ is very
Sure,
specific.
it's a different function.
Yeah, this is not really going to do anything here. Yeah, this thing is actually used a lot, like the plus plus, mostly in loops. It's weird. You would think why is adding 1 like a special thing by itself? But in programming, a lot of things go one thing at a time. Like a
Yeah.
lot of things go one thing at a time, which is why adding 1 is actually really super useful.
I have a question.
Yeah.
Say you want to put like 3 pluses.
So you want to do plus 3?
Yeah. Is that even?
You can't really do that. Like that's not really like that. You don't want to be seeing this kind of thing. Like this is not really valid. What you would do is if you want to add something 3 times, you'd probably do lives plus equals 3 on a separate line like that. Or if you really care, this thing is special though. So this is different actually from doing. Does anyone know why this is different? What is the difference? What would this print out versus? Wait, so it's kind of a trick question because these two will print the same thing. I'm sorry, these two will not print the same thing. This will print the same thing. Kind of confusing. I'm going to put 3 things up here. Hopefully make it. Because you know what the result is here, right? Like, I'm just going to do these one at a time. All right. What does this print out here? That's 30, right? Cool. Done. What does this print out here? 40. Cool. Done. What does this print out here? 40, right? All right, cool. You guys got it. That's all right. You're totally right. But there's a difference between this printing out 40 and this printing out 40. Why? Because this one here, actually, this thing out here actually changes. It actually adds 1 to lives permanently. This thing says, take the value of lives, take 3, and make it 4 instead. This thing temporarily adds 1 to lives. So if I were to do this, and I did cout lives, what is lives here? What will this print out here in this case? It'll print out 4, right? What will it print out in this case here? 3. That's the difference between the 2 ways to add 1 to something. The plus plus will actually change the variable right there, which is it's used so often that they have to combine it into one single operator. This is a temporary thing. It's not. You're not changing lives. You're just adding it temporarily. All right. Okay. All right. I got 2 more files to go through.
Only like 2 more days.
You guys, your brains hurting yet?
Nope.
No, almost. It's a lot. This is what I'm talking about. 4 hours in a day is a bit much, but you guys are gonna have to practice this to really soak it in. You guys are just barely starting to absorb some of this stuff. It won't really click at all until you do the homework, until you start practicing, until you actually struggle and write this stuff. You guys are, mostly I'm just kind of briefing you. Think of this as like a mission briefing before you guys go out in the field and like learn it for real. Because like you can do as much training as you want to. The moment you step out there, you're like, fuck, this is a lot harder than it looked. Like I thought I understood it in class and now I can't do it here because you have to build that bridge yourself. You can see the exit. I can tell you how to build the bridge. I can show you that's where you want to go. But you guys actually have to like physically do it. And that's the hard stuff. That's like working out, right? Like, it's like, oh, you can watch videos like, oh, this is how you do a squat, this is how you do a deadlift. And like, oh, that looks easy. You get to the gym, you're like, oh my God, this is way harder than it looked. But yeah, but eventually it gets easier and easier, right? So, all right. Constants. If you put a keyword const in front of it, that means that you are not allowed to change that variable after you have created it. So this means that this alien point value will be 150 forever, as long as your game is running. If you try to add 1 to that thing, or you try to modify that variable afterwards, you will get an error. So it will not compile. It will tell you, nope, can't do it. You told me it was constant, now you're trying to change it. In fact, let me show you what that error is. So if I take this alien points and I try to do something like plus plus to it, there's an error. You get an error that says plus plus needs L value. That means that, hey, you're trying to add something to something that can't take it. And L value is a value that can be on the left-hand side of an assignment operation. It means that L value means left value. So like it can mean like here. So this thing is not allowed because it's a constant. That's just a way for you to declare something like I talked about, where I had like const int max wow level maybe was equal to 60. Every time we release an expansion, someone's going in there making it 70 or 80 or 90, because this value is used everywhere in your code. I talked about tens of thousands of C++ projects. There might be 8,000 files that use this constant. They refer to this by variable. It's not like if I want to print out the max level, I don't just type 90 somewhere. So if I want to say, if I want to type out the max level in WoW and I do cout, the max level in WoW is 90. I could do that, right? But what about when I release an expansion and I make this thing 100? This thing still thinks it's 90, right? So here's the way you fix that. This is why constants are important. Instead of printing out 90, you just do that. You just print out the variable name here. So whenever I change that, that thing updates too. This thing is not just in one line in WoW. This thing is in like tens of thousands of places. If I want to change the max level in WoW, I don't want to go over 10,000 different files to update that one number every time. All you do is update that one thing there, and everything is hunky-dory. All right, hunky-dory. That's what they say in WoW. All right. So here's a variable assignment. Score is equal to aliens killed multiplied by alien points. What is this? What is score going to be here? What is alien points times 150 times 1500? Yep, that's all it is. That's constant. Pretty simple. Okay, enums. I think we have time to go over enums. Enums are just constants that you declare all at the same time, all at once. So see here how I declare like max WoW level E100 and alien points to 150. And enum like this. Let me make this a little easier for you guys to read, because typically you don't do it all in one line. You do it like this. This structure here, this is something you're just going to have to memorize. Like you're just going to have to know enum. You have a keyword enum. You call your enum whatever you want to. I'm going to call my enum kappa. Difficulty. You can call it whatever you want to. These are the same thing as constants, where I had up there. Sorry, it's the same thing as, I'm going to get rid of this WoW level. It's the same exact thing. It's like you're doing this on every line here. But it's an easy way to kind of take all these things and do it all at one time. And then C++ will magically inject values in there. What C++ is actually doing, that it's making it so you don't have to do it yourself, is doing this. And it's giving each one a unique number like that. So it's doing that by default. Automatically it gives these numbers, so you don't have to type those in. It'll do that starting from 0 all the way up to however many you have. Yeah, but these are, this enum, each of these numbers here, each of these variable names is the same as one of these. So I can just use them like regular variables. And as a benefit to declaring an enum, you get to use that thing as a variable type too. Why is this? Why would you use enums? And see here how you can actually assign whatever values you want to the enums. Enums are seriously one of the coolest things ever, because a lot of times you have things like max WoW level, but most of the time you have things that are lists of things that you want to give each one a unique number to. Difficulty is one. Let me give you guys another example, like rarity, item rarity in Diablo. Enum values for this would be like common, rare, epic, legendary, ancient, legendary. These are common. These are enumerations in Diablo. What are some other things that would be Halo difficulty? What are the Halo difficulties? Normal, easy, normal, heroic. Okay. Or let's say these are difficulties for Halo. Oh yeah, you could do weapons like this too. You could say like weapon types. Let's say I have like let's just say like semi-auto, sniper. These are generic. Like these are across all the weapon types. I know Halo kind of only has like one, but they have like multiple types of snipers. Rocket launcher. I don't know, like pistol. Yeah, you guys get the idea, right? And the reason is that sometimes you want to know, these are just variables. This is just 0, 1, 2, 3. That's all they are, just numbers, but they're constants, just like how the max level was a constant. But it's just an easy way to do this. I could do this without using enums. I could actually do this just by doing constants on each one of these. So if I did like const int, I could do that. This is the same exact thing pretty much. I could do this like this. Rocket launcher, pistol. Like that. That's the same as me doing the enum, but that's, for one, that's more typing than I want to do. Two, I don't get to name it something cool like kappa difficulty or like weapon type, right? And the reason why that's cool is because I can use that as a variable type here. So see how I'm actually typing in the word easy? You can actually make, if I had it as a Halo difficulty or a Halo weapon type, if I undo all this, I can make weapon types as a variable type. Currently equipped weapon, right? Or last killed by weapon type equals rocket launcher. This might be a line in Halo, right? Like maybe as part of the kill feed here, you want to remember what the last killed by weapon type is, right? So you have weapon types as the variable type with the variable name and then what it is, right? You can do this because I have an enumeration. If I want to do the same thing without using enumeration, I would have to use an integer. these are basically the same thing here, but this is an integer and this is a weapon type. Why does that matter? They're both basically the same. This makes it more clear to everyone who's using it. It also means that whoever's reading this knows that this is a weapon type enumeration as opposed to this, which is just a number, which this thing could be 17. That's valid. You don't want to get killed by weapon type 17. That shit is crazy. All right.
So if you put, for the weapons type, if you put like 3, it'd be rocket, right?
Yeah. Yeah, exactly. It starts with 0, 1, 2, 3 would be pistol. So I could do this. I could do this. Which weapon type is 1 represented by?
Sniper.
Sniper. It starts at 0, 1, 2, 3. But notice I have a little red squiggly. So this is the other benefit, is that if you have an enumeration like this, it actually wants you to use these instead. But if I printed this out to C out, it would print out 1 to me. So it actually requires me to use these values like this. So I can do pistol. If I try to do like 0 here, oops, get rid of all these. If you try to do this as 0, even though I know 0 is a semi-auto here, I know that 0 is the number here, it can't directly convert it. It's telling me there's an error here because it can't convert from 0 to that automatically. But that's fine. This is a very common thing. And the way you work around this is something we're going to get to later, is you convert it to a weapon type. Like that. And that will say, oh, I'm telling you it's 0, but what I really mean is actually semi-auto right there. That's actually converting it to be one of the enumerations. Don't worry about that too much for now, but that's actually what it ends up being. I do want to talk about this here. So notice this enumeration here for ship cost. Okay, so here are the numbers for this enumeration, and it prints it out to the screen. Okay, so let's talk about what it's actually going to print out. The fighter cost is 25. I said it goes down in order. What do you think bomber cost is going to be set equal to? 50. But cruiser cost is already 50.
So 35.
It doesn't divide the two at all. It actually just increments it by 1. So it says fighter cost is 25. Bomber cost will be whatever the previous one was plus 1. So this will be 26. That's what. If you can leave out numbers, it's weird. You can kind of just leave out these assignments as much as you want. You don't have to give them in there. If I do this, what's cruiser cost going to be? 27, right? So it just fills in the gaps for you by adding 1 to it. So what is? Let's do this. What is that going to print out here? What is that? It's going to print out the number 26 to the screen. This is going to print out the number 26 to the screen. So what is this going to print out? 24. So let's run this. It's 50 minus 26. It's kind of a crazy puzzle, right? Put a breakpoint here. So there you go. So I printed out bomber cost up here. And the upgrade cost will cost 24, right? All right. The enum thing? Oh, this bottom part here? Okay. So this is just an arithmetic operation, right? So if I just took the number, so all you do is you take the value of these and you substitute them. So what's cruiser cost right here? 50, right? So I could just put 50 in there. What's this value here? It's this bomber cost, right? And what's that? Oh, okay, 26. Yeah, this is 26, right? So that's what it actually ends up being, 50 minus 26. Right, so see how this thing is leaving off? This thing, I didn't type in 26 up there. That's what C++ put in for me. It adds 1 to the previous one. See how this thing is 25 right here?
It just goes in line with sniper.
Yeah, you have the option of either typing it or leaving it off. Yeah, you can do a different number too. Yeah, you can actually do like 28. You can do like that number if you want to. That's fine. They don't have to be in increasing order.
So
It
if
just
you
means that if you leave one off, it'll add 1 to it, and that'll be the next one.
If you didn't have 25, it would be default 0.
Default 0, then 1, 3, 1, 2, 4, 4, 1, then 50. Yeah, your enumerations would be that's a bad enumeration. Typically, they start from 0 and go down. Oftentimes, you'll have an initial value and maybe go down. We use enumerations for things like, a perfect example is a keyboard and gamepad inputs. Remember how I said how you can take inputs from the game controller and the keyboard eventually? Well, every single key and every single button on a gamepad has unique enumeration associated with it in Windows. You'll actually see it. It's called an X input, like enumeration. So, I'll show you. So every single one of these, I want to see the code here. It's actually better in SFML. Sorry, while I bring this up here. So see here how it has an enum. This is an example of where an enum is mapping the keyboard keys, every single keyboard key to an enum. So these are all the keyboard keys that you can have. So every single keyboard key is represented. So when you're writing your code, you can see what key has been pressed. If I press F, I can compare that to the enum F up here. So F right here, what does I see? A is 0, B is 1, 2, 3, 4, 5. So F is 5 in this enumeration. If I want like control, like the control button, maybe shift sprints in my game, right? I want left shift to sprint. Well, there it is right there. That's the code for it. That's the enum for it. There's numpads, there's function keys. There's a similar enum for gamepad. Like gamepad has what's called cross buttons. So you know the face buttons like A, B, X, Y. It has one for each of those, one for each bumper, one for each trigger, one for each analog stick, the click on its sticks, the start back buttons. As well as it has special ones for how much you're pressing the analog stick, whether you're pressing it full or not. So those are special. All right. Okay, so now I'm going to give you guys homework. Finally, that's pretty much it for the lecture. Let me stop recording this.